Good afternoon, my YouTube viewers. In this particular video, what we're going to do is we're going to forecast inventory using an ARIMA model. And so we're going to create a Python program to do that. And then in order to create the Python program, we're going to need to import 4 libraries. And these 4 libraries are going to help the program to execute. So the first library that we're going to import is NumPy as NP, which is the numeric library, and it also creates NumPy arrays. And then the second library that we're going to import is NumPy as NP, which is a data processing library, but it also creates data frames in series. And then the third library that we're going to import is matplotlib.pyplot as BLT, which is the visualization library. And then from statsmodels.tsa.arima model, we're going to import ARIMA. So statsmodels is Python's statistical library. TSA is the time series analysis module within statsmodels. And ARIMA model is the is a function within TSA, and ARIMA is the actual model that we're going to be using. So we're going to generate some synthetic inventory data over a period of a year. And before we do that, what we're going to want to do is we're going to want to set our seed. So we set our seed by typing np.random.seed, and you can type anything you want in between the brackets. And so basically you set your seed so every time you run the program, the variables values initialize to the same numbers. So we set up weeks equals pd.date range brackets start equals 2023-01-01, periods equals 52, frequency equals W, so that's 52 weeks. Trend equals np.linspace brackets 500, 300, lend weeks, and that's a gradual reduction in inventory levels. And then so we're going to access week number using weeks.isocalendar.week. So seasonality equals 50 times np.sign brackets 2 times np.pi times brackets weeks.isocalendar brackets .week divided by 12. So that's seasonal restocking patterns. And noise equals np.random.normal. Normal is a normal distribution. Brackets 0, 20, len weeks. And that's random noise to simulate fluctuations. And inventory levels equals trend plus seasonality plus noise. So now we're going to create a data frame for the inventory data. Inventory df equals pd.dataframe brackets, curly brackets, week, weeks, inventory, inventory levels, and inventory. And then so what that means is week is the first column of data and inventory is the second column of data. And then what we're going to do is we're going to set our index. So inventory df.setIndex bracket week, in place equals true. So what that means is the week column becomes the index and the inventory becomes the first column of data. So we're going to split the data into training and testing sets. So trained data equals inventory df square brackets inventory square brackets 40, and you're going to use the first 40 weeks for training. And test data equals inventory df square brackets inventory square brackets 40 and you're going to use the remaining 12 weeks for testing. So we're going to define our model which is the ARIMA model. So model equals ARIMA brackets train data, comma, order equals 1, 1, 1, and that's your PDQ. And then you have to remember in a previous video, I gave you the code to actually calculate the PDQ. And so in reality, what you would want to do is you'd want to calculate the PDQ to get the best calculation for the order, but we haven't done it in this particular program. We just use order. You just use order equals 1, 1, 1. But that's what, if you go back and look at my other videos, then there is code in there to calculate the PDQ. And so model fit equals model.fit. So we're going to forecast the inventory levels for the test period. Forecast equals model fit dot forecast brackets steps equals lin test data brackets. Forecast index equals test data dot index, and you use the test data's index for plotting. So we're going to plot the data onto a chart. So plt.figure brackets fig size equals 6, 4 brackets plt.plot brackets inventory df.index, comma, inventory df square brackets inventory, comma, label equals observed inventory, comma, color equals blue, comma, alpha equals 0.6. And then plt.plot forecast index, comma, forecast, comma, label equals forecasted inventory, comma, color equals orange, comma, line style equals dash. And then now we're going to put a vertical line in the chart, plt.axv line, brackets, x equals train data dot index, square brackets, -1, comma, color equals gray, comma, line style equals dash, comma, label equals train test split. So we're going to add labels, title, and legend to the chart. So the title is inventory level forecasting using ARIMA. The X label is your date. The Y label is inventory level. And then we've got a legend and a grid. We're going to plot the chart and show it. So this is what we plotted. The inventory level forecasting ARIMA. And as I said, it gives you the blue is your observed inventory, and the orange is the is the forecasted inventory, and the gray is the where you split the inventory between the observed data and the forecasted data. And one thing that I would say is, in order to get the optimum value from the forecasted data, is you need to calculate your PDQ. And I've got code on how to calculate the PDQ, and I showed it in a previous video. But that's what you need to do to get optimum forecast levels. So that concludes this video. The next video is going to be another time series forecasting subject. So I hope that you decide to watch it.